This is Mark Maffett. I'm going to be discussing a technique for the placement of anatomic femoral tunnels for ACL reconstruction utilizing a sequential asymmetric drilling technique. This technique is done through an anteromedial portal drilling, which allows placement of a truly anatomic femoral tunnel. I used debridement of the ACL stump and a minimal notchplasty, really just to allow visualization. If the ligament is placed in the anatomic position, the notchplasty is not that important, but one needs to be able to see landmarks and see the back wall for this procedure. Here you can see the placement of the old ACL. The top is Blumenstadt's line, the residence ridge, which marks often the anterior border of the ACL attachment, and behind that you can see the back wall. So the area between Blumenstadt's line on top and residence ridge in front is the area where the ACL lives. So I'm going to select a point in the anterior part of that ACL footprint. If one wants to go in the true center of that ACL footprint, the guide pin very well can go into the back of the knee or out the side of the knee in a non-ideal place. But I can put this tunnel anteriorly where there's a lot of advantages which are delineated in my paper that supports this video. But we can start in the anterior aspect and create a truly anatomic femoral tunnel. So in this case, I'm drilling a standard guide pin through the area I've selected with my awl. This technique, I don't use any type of guide or over-the-top localization for this. I then come over the guide pin with a 4.5 drill bit, and this drill bit I'll use to start the tunnel and go out through the outside cortex. That's important to allow movement of the pin. Also use this to gauge the depth of this tunnel. As it goes through the outside cortex, you can see how deep it is. So in this case, you can see I can move this guide pin, and the idea is that with additional flexion of the knee, I can bring this pin to the posterior inferior aspect of my previously drilled tunnel, and using sequential asymmetric drilling, I can make this tunnel gradually move backwards. So in this case, I have a 6.5 drill bit, which is next. You can see that it's not drilling anything anteriorly. It's taking the entire additional width of this drill bit posteriorly and inferiorly, which drops you right into that anatomic ACL footprint. There's a lot of other advantages to this, with only temporary need to hyperflex the knee during the actual drilling, but ingress of the reamers into the knee can be done at a less flexed place. So in this instance, I back the pin up into the tunnel, which I'll show you better going forward, but I can check my landmarks. So I get a shaver, I check I'm still below Blumenstadt's line, I'm still behind residence ridge. I can see how much back wall that I have left. I know how big a graft I have, so I can do the math in my head to see what my ultimate drill bit's going to be, and I work up to that drill bit. So I start off with the 4.5, then the 6.5, which I've done, and then I'll usually use one more intermediate drill bit before the final drill bit size. And again, we're sequentially asymmetric drilling this tunnel to allow this to be placed in a truly anatomic position. So we bring the guide pin back down in the hole. It's been brought to the outside. We grab it with a grasper. It gets it out of the way to allow us to unflex the knee to check those landmarks. Pull that back out through the anteromedial portal, and here's the next size drill bit. So as you can see, I've hyperflexed the knee. I am asymmetric drilling. It's not drilling anteriorly and superiorly, it's drilling posteriorly and inferiorly. I have a 3D CT cadaveric study from the lab that actually proves that this is actually happening with the three-dimensional CT scans and showing the beginning and end results of these tunnels. So again, I pull the guide pin back up into the tunnel to get it out of the way. I can take the knee out of hyperflexion so you can see. We can get a shaver in there. If you're teaching a resident, this is very good to allow them to see what they're doing, to check their progress, to make sure you're not blowing out a back wall and that your tunnel is reproducibly, in every case, in the truly anatomic position. So again, I like the placement. Again, it's below where I want. It's behind that anatomic footprint. I've got the back wall close to where I want to be. And this is the time where I'll do my final drilling, depending on the size of the graft being utilized. This technique can be used for hamstring grafts. It can be used for patella tendon grafts or allografts. Again, pulling the guide pin back out the anterior medial portal, and I'll prepare this for final drilling. So if I don't like the back wall is too thin, I can drill more influenced anteriorly to avoid that back wall blowout. If I like where it is centrally, I can take maybe another millimeter from the back, which I'm doing in this case. I don't want to take as much back wall as the drilling will allow me. I'm keeping the pin fairly centrally in this case, but it allows you that freedom. So we make the final drilling of our femoral ACL tunnel, and taking the knee out of flexion, you can see we've got about a 2 millimeter back wall, which is what I was shooting for. I've kept the placement of the tunnel behind where our original guide pin was placed. This has been sequential asymmetric drilling posteriorly and inferiorly. And again, I like the back wall here, about 2 millimeters. Some people might place this tunnel a little further down. I like this position. You can see 12 o'clock. You can see this is probably 2 to 2:30. I kind of shoot for the 2:30 position, not a truly radical 3 o'clock position, but more of a 2:30 position.